Hello, my dear students. In today's video, we are going to learn about a new topic, that is laws of exponents for rational numbers. You know that a number can be expressed in different ways. In lower classes, you have learned how to write a number in the expanded form. Then you learned how to write a number in the product form. And then you learn how to write a number in the exponential form. Also, we have learned some laws of exponents which are applied for integers. But now we are going to learn how to apply these laws of exponents for rational numbers. Once again, I welcome you all to your own channel, Noble Mathematics. Will find a way or make one. What is the exponential form of a number? Let us see an example. 1024 on prime factorizing, you get 2 into 2 into 2 into 2 into. How many times 2 is multiplied? 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this 1024 can be written as 2 raised to 10, which is called the exponential form. And this is called the product form. The first line is in the product form and the second line is in the exponential form. In this exponential form, 2 is called the base and 10 is called the power or exponent. In today's session, we are going to learn how to apply the laws of exponents for rational powers. Rational powers means a number which is in the form of p by q is in the power. And also a rational number can be the base. So we are going to see what are the different laws which can be applied for rational numbers. Laws of exponents. We have around 10 laws which can be applied for rational numbers. One by one, I will write on the board and I will explain with the example. The first law is x raised to m into x raised to n is equal to x raised to m plus n. This is a law which can be used for multiplying two exponential expressions with the same base but of different powers. For example, 2 raised to 4 into 2 raised to 7 is equal to 2 raised to 4 plus 7, that is 2 raised to 11. This is the first law. Second one is x raised to m divided by x raised to n is equal to x raised to m minus n. This is a law used for dividing two exponential expressions. Example, 5 raised to 8 divided by 5 raised to 4 is equal to 5 raised to 8 minus 4, that is equal to 5 raised to 4. The third one is x raised to m the whole raised to n. This is a law when there are more powers for the same base. So in this case, it is equal to x raised to m into n. For example, 7 raised to 3 the whole raised to 4 is equal to 7 raised to 3 into 4, that is 7 raised to 12. The fourth one is x raised to m into y raised to m. This is a law used for two exponential expressions with different bases but of same power. It is equal to x into y the whole raised to m. For example, 4 raised to 3 into 5 raised to 3 is equal to 4 into 5 the whole raised to 3, 4 into 5, 20 raised to 3. Fifth one is x raised to 0 x raised to 0 means the base can be any value but the power is 0. X raised to 0 is equal to 1. This is a law applied for any expression with a power 0. If the power of any expression is 0, then its answer is always 1. For example, 7 raised to 0 is equal to 1. 100 raised to 0 is equal to 1. 1 by 10 the whole raised to 0 is equal to 1. So, if the base is anything, but the power is 0, then its value is always equal to 1. But 0 raised to 0 is not defined. Sixth law. It is x raised to minus 1. If the power is minus 1, then it is equal to the reciprocal. So, x raised to minus 1 is 1 by x. For example, 3 raised to minus 1 is equal to 1 by 3 and 1 by 2 the whole raised to minus 1 is equal to 2. So, when the power is minus 1, you write the reciprocal only. Next one is x raised to minus m. Instead of 1, I write m. X raised to minus m is equal to 1 by x raised to m. Example, 7 raised to minus 3 is equal to 1 by 7 raised to 3. Whenever you have to evaluate the value of an exponential expression, to find the value of an exponential expression, make sure that the power is or the exponent is positive. If the exponent or the power is negative, use the suitable formula or identity to convert the negative power to positive. Now I am going to use some of these laws for a rational form. That is, p by q is a rational number. So p by q the whole raised to minus 1 is equal to q by p. Example, 3 by 8 the whole raised to minus 1 is 8 by 3. It is also simple, the reciprocal. Ninth one, similarly, if you have a p by q the whole raised to minus m, then it is equal to q by p the whole raised to m. P by q the whole raised to minus m, that is negative power. To make the negative power positive, we just write the reciprocal, that is q by p. Example, 3 by 8 the whole raised to minus 2 is equal to 8 by 3 the whole raised to 2. 10 to 1. Nth root of x. Nth root of x means here x can be any rational number and n can be also any rational number. Then it is equal to x raised to 1 by n. This is an important one. So whenever the exponential forms are under the root, then we can use this law. For example, cube root or third root of 5 is equal to 5 raised to 1 by 3. It is very simple. If instead of 5 some other expressions come, then you write it there. And instead of 3, if some other value comes, you write here. So 1 by 3, that is always a fractional form. So these are the 10 laws to be applied for simplifying the exponential expressions of rational numbers. It is not only important to by heart these laws, but also to identify which law is to be used with which question. I hope all of you understood the different laws of exponents. Learn all the laws with examples and get prepared for doing different types of questions based on these laws. That is all for today. In the next class, I will be coming with a few questions based on laws of exponents.